Hi, this is my solution for Paul McWhorter's Pico W lesson number 28 when we're using the Pico W as a server and we're using the PC as a client. Now here we have a rough approximation of Paul's program that he wrote. The one on the left is the server, the one on the right is the client. Now, I've got a couple of things I don't like about this. In the client one, server address, that's hard-coded in. Now, I don't like that, and we'll see if we can look at a way around that. And also, in the server one, he didn't use Wi-Fi info. His file was called secrets. But it means that you're storing the secrets on the Pico W, and anyone, if they can just open it up in the editor, and they can find out your SSID and your Wi-Fi password. So I'll see if I can show you something that will help you with that as well. And also in the lesson, and people in the chat session agreed that it would be a very good idea to give the Pico W a static IP address, but I don't think this is so great. I give my Raspberry Pi's static IP addresses, and that's because you need to know them for if you use SSH and VNC, but you can't SSH or VNC into a Pico. So anyway, we'll see what we can do. I'm going to run the server. No, first of all, I'm going to disconnect because that was already connected from before. So in order to check whether things are working, you always have to disconnect. So you plug it in again. Right. Now I'll run it. And it's waiting for connection, and there we have the server IP address is 192.168.1.1.23, which just happens to be the one that is hard-coded into the client. So I'll run the client. What is your command? Hello. Message received on the server is hello, and then it puts it back saying message from server and received your command hello. Right, okay. Red. Go. Everything seems to be working fine. So we'll stop that and stop that. Now the reason why I actually ran them to begin with was so that I can go into my ISP homepage, and count yourself lucky this isn't in French because it is a French thing. And there we have the things connected to Wi-Fi, my desktop PC, little laptop, 2 iPads, and there's something there called PYBD. So if you click on that, and it says that it's called PYBD. I didn't call it that. The ISP software did that for me when I plugged it in, the router software, sorry. And then you can see the IP address is 192.168.23. Right, so if we go back to both Thonnies, on the client side, which is on the PC, if you say in the shell import socket, and then you go socket, where's the dot, get host name, sorry, get host by name, and then you put PYBD like that. It gives you the IP address, which is all very handy. So I decided to put that in the program. I'm very squished here. That's better. We'll close that, and I have amended Paul's program, and my version of it, instead of that server address equals hard coded, it's like that. Only you ought to be PYBD. Yep. We'll run that, and it's connected. Go. No, I think I'd already stopped that. Right, so I'll unplug it. I don't know, I think there was an existing thing plugged in. Right, we will run. It's always good to unplug and plug in again, otherwise you don't know where you are really. Right, 192.168. Right, we will run my program, and it says, what is your command? Go. That's okay. Red. That's all working okay. Stop. Completely ignores me. Right, that's fine. So I will stop that, and I will stop the server, and we'll go back into the router homepage, and you can name your device, because PYBD isn't very useful. If you connected another Raspberry Pico W to it, it would come up as PYBD. It's automatically PYBD2, then 3, then 4, I think. So I thought it would be quite good if you called it Pico W Server 1, and then you save that. I don't know what character, ooh, it disappeared. I don't know what characters you can put in there. You can't put spaces in, so I just do bumpy text for that. So we'll go back into Thorny, open up both windows. Right, just to make sure we're starting off from clean, I will plug that in and run the server. It's connected. We will run this. No, doesn't work. And that is because I've renamed the jolly old Pico W. So if I put in Pico W Server 1 and run that, there, works like anything. Now I think that's pretty smart myself. Other people might disagree. So we will press stop on that, press stop on that, and if I close that, and just so I don't get confused, I get rid of Paul's version of the client. Now, my other gripe, apart from the hard-coded IP address, is the fact that you have the Wi-Fi info there. Paul's was called secrets, so if we go into Raspberry Pi Pico, into the lib, there's secrets, and you could just open it and there you have the SSID and the password for anyone to come and look at. So that isn't that great. So I thought I would solve that problem, because you don't want anyone to get hold of all your Wi-Fi info. So I wrote a program that looks a little complicated. Now the ubin ASCII is a way to be able to get the MAC address of your Pico W. And what you do is you come down here, and that's when you're getting the MAC address in a format you can actually use. So it will be like 28 CD C1 07 dB, like that. And then it prompts you for the SSID of your router, and in fact you can run the program and use the SSID and the password of another network. It doesn't have to be the network you're on, but it means it will only work on the network that you've set up, if you understand what I'm meaning. And then you ask for the password, and each time you encode it, and the way you encode it is you take the password and you take the MAC address, and you go through character by character, and you add the two characters together, and you add them, you put them in an array, and this will give you an array which you can then pass to your decode program. So we'll run this, enter SSID, my house, my password. Right, and now you get given the encoded SSID, an array of numbers, which you think, oh, that's very useful. So what you do now is you open up this program, which is to decode it. And this is the program that you store on your Raspberry Pi, and any program that wants to connect, you will just import this program at the beginning and it will connect for you. As before, the decode does exactly the opposite of the encode, and then you're connecting. It says down here you connect with that information, and you connect, and it goes round and round and round. And incidentally, this is the preferred form, as opposed to go while WLAN is connected not equal false. No, equal false, sorry. It's much better to go while not WLAN is connected. If you have a Boolean, it's frowned upon to go whether it equals false or equals true. Anyway, that's by the by. Now in this skeleton, it says replace SSID and password by the arrays output by encode. So you go to shell, where you'd seen them before, and you copy that array, including the brackets, and you go copy, and you paste it in there, and you go back to shell, and you copy the other one, and you paste it in there. All very simple. Then you go File, Save As, on the Raspberry Pico, in the lib, and then you save it as decode.py. But I'm not going to do that, because I've put in a rubbish SSID and a rubbish password. So I'm going to cancel that and use the one for the demonstration. I'm going to use the one that I've already set up, so we'll cancel that. At this point, rather than saving it to the Raspberry Pi, you could save it to your PC, and then you could run a program to compile it, and then move the compiled program over to your Pico lib. I'll tell you about that later, but it's just that at this point that you ought to do it. So we don't need that one. We need to go into we'll open, we'll go into the Pico, we'll go into the lib, and we'll have a look at this decode.py. This program is exactly the one I showed you before, only it's saved on the Raspberry Pi, Raspberry Pico, and it's got the correct numbers for the jolly old jolly old SSID and password. So if we run that, it doesn't appear to have done anything. But if we unplug it and plug it in again and press stop and press run, there, you can see it was doing its connection, but it still hadn't done anything because this program isn't really wanting to do anything. So now you've seen that in action, I'll get rid of some of these things. We don't need Paul's version, we want my version. So this is my version of Paul's program, and all I've done is I've taken out the references to the file containing the SSID and the password, and I've taken out the connection because it all does it in import decode. So we will run the server, and it didn't go connecting because it was already connected. And then we'll run my client. What is your command? Go. Yep. Stay. Yep. Red. As you can see, it's acting exactly the same way as Paul's did. So that is all fine and dandy. Now, the problem with this decode.py is that anyone could go and have a look at it. And it might not mean much to anyone. Well, if you knew what you were doing, you could go into this program and replace that line, that bit there, my IP equals connect, by print. And what that would do is it would actually print out your nicely decoded SSID and password. So you don't really want anyone to get their hands on it. So what you and equally, if you go into shell and you go import decode, this is how you can find out a lot of information on things that people might want to keep hidden. So if you go dir decode, it will tell you all the general dunder class, dunder name, dunder dict, whatever, connect, decode, network, and you think, well, nothing exactly interesting. So you go decode dot my IP. Now that shows you any variables in the program, you can actually find out what they are. So this is why in the program you'll notice I don't have, apart from your silly variables like within that function, which no one can see, and oh, no, there isn't anything else there. I haven't done anything with variables. It would have looked easier if I'd gone decoded, if I'd gone decoded SSID equals that lot, and decoded MAC address equals that lot, and then I could have just gone my IP equals connect with the SSID and the password. But that would mean that anyone looking at it via DIR would be able to see what there are. So that's why I have no variables. And then you can have another look to see what else you can find about it. And that doesn't tell you anything either. So this is all fine and dandy, apart from the fact that people can go in and have a look at it. So this is why you need to, if you're really wanting to make it very secure, you at the time when you were saving this decode program, you wanted to compile it, and then it will come up as being a .mpy file, and then you save that to your Pico lib file, and then no one can look at it, and no one can find out anything about it with the DIR or the help. And it's a bit of overkill for something this silly, but it's quite a good idea. So now we want to get on to the real program. So if I get rid of all the dross that we don't want the skeleton, no, I don't want to save it, we don't want the decode, we don't want the encode, we don't want that, we just want the program. And have I stopped that? Yeah, well, I have now. Anyway, this is my program that I've kind of cobbled together from other lessons, and the server is doing various things. What it can do is you can turn the LED onto various colours, but it has to be a specified colour. If it isn't in there, it will turn it off and say invalid colour. And then it will also, you can see, this looks vaguely familiar from lesson 26, I think, when you're drawing a Lissajous curve. And so you come in, and the program, first of all, when it starts, it displays on the little OLED server ready, and then it waits until the client asks something, and then it gets a command, and I don't know what that line's doing in there, that's left over, ignore line 50. Then it says if it's stop, you stop the server, and if you're asking for Lissajous curve, it will take the parameters which you put in for it, and then it will display the Lissajous curve, and then it will turn off the display and go back to the client and say hello, this is what's happened, or no, ignore line 70 as well, and then if you weren't asking for Lissajous curve, you turn on the LED to the selected colour, or it tells you invalid colour. So it's all very simple. But what we want to do first is, the whole point is to be doing this with not connected to your computer. So you go File, whoops, File, Save As, Raspberry Pico, and you don't go into the lib this time, you just go here, main.py. Right, that's okay. Now, I need to organise things a bit better. I'm getting rid of that. I want the camera. Where's the camera? Or I'll shove the camera down there. Oh, I shove the camera. Oh, it doesn't matter where I shove the camera. Anyway, I've done it again. We do not want a picture of the bathroom. Right, so I will unplug the Pico W from my computer and I'll plug it into my battery. There, completely disconnected. And it will eventually, I don't know if you can see that, it's very difficult to read. That says server ready, which is fine. And in fact, I can put the camera over there because that program isn't running at all. So we will start the client running. What is your command? We will go capital red. And it turns the LED on. And it says there, which you can't see, LED is red. Well, that's good. Right. Blue. It doesn't matter about the case. That's blue. And that says LED is blue. And it sends back the message from to the client saying LED is red, LED is blue. Now we can go cyan. Cyan's working fine. Green with two ends. No, I don't like that. So it says on there, invalid colour, and the message from server is invalid colour, and it turns it off. So then we can go, what would be nice? I'd quite like orange. Orange. So there we go. LED is orange, and it turns on the orange light. Now, if we want to draw a curve on it, we go Lissa, comma, and then if we just do the standard Pringle, it's A is 1, B is 2, and I'll put a speed of 4 on it, and we'll see what happens there. And there we have the Pringle. And then it disappears, and it sends a message back saying Lissa Zhu curve has been displayed. And it doesn't turn off the LED. So you can now, even though you've done that, you can turn it to blue and it's fine. And it says LED is blue and LED is blue over there. And you can even go Lissa Zhu curve. You can type in very much longer because it's only seeing whether it starts with Lissa Zhu, and then if you go 3, 2, make it a bit faster, and there we go, it's displaying the other way round and turns off. Wonderful. Now the only other command it does is if you type in stop, it says server stopped. Oh, it's disappeared. And then message from server, server stopped. It turned off the LED. And now if you go red, it just hangs because the server has been stopped. And I think there's my program. And excuse me. Sorry, I'll turn it off.